Hi, welcome back to using Terraform with Azure Cloud. I'm Matt, and in this video, we're going to be taking the configuration we started in the last video and expanding on some Terraform concepts that will help make your code more flexible, reusable, and readable. So let's dive right in. And remember, all code from these videos will be available on GitHub once these videos have been published, so check it out if you'd like to follow along. The link is in the description. The first concept I'd like to show you is tying resources together dynamically without having to hard code all of your values. Take a look at the resource group and storage account here and see if you notice anything that's repetitive. First thing you should notice is the resource group name appears twice, and so do the location and tags. Although this code will work perfectly fine, the issue comes when your configuration grows and you have to start changing some of these values. For example, let's say I wanted to move both of my resources to Central US instead of East US 2. Now I have at least 2 lines of code that need to be updated. And if we have to update tags too, then that's even more lines of code to remember to update. As the configuration starts to grow, that's going to become more and more time consuming. So I'm going to show you how we can have all these repeated values driven by just our resource group. What we're going to need to do under storage account is to reference the resource name for our resource group. Now the way I usually do this is by copying and pasting the resource I'm using. That way I avoid any typos. So let's go ahead and delete the resource group name value from the storage account. Next, we're going to copy the resource type, which is AzureRM resource group. And we're going to paste that in the resource group name attribute for the storage account. And since we could have more than one resource of that type, we have to specify the name of the exact resource we want to get information from. To do this, let's put a dot after AzureRM resource group. You may notice IntelliSense windows popping up as you're working. We're going to ignore those for now until after we finish up. Now let's go up to the resource name for RG1 and copy that. Back in the storage account, we're going to paste that name to the end of the resource group name attribute, after the dot. Now we're not quite done yet. Let's put another dot after RG1. Let's put another dot after RG1, because we need more than to just return the whole resource group. This attribute is looking for the name. Some attributes will be looking for the ID of a resource, and some you'll just be passing strings of data around. Since we need to pass the name here, after the dot, we're just going to type name. One thing that's good to mention here is we just created an implicit dependency with these 2 resources. The storage account now implicitly depends on the resource group, so the AzureRM provider will make sure that it creates the resource group first before it creates any of the resources that go inside of it. It will also make sure the storage account gets deleted first before deleting the resource group during a destroy. Now I've seen some implicit dependencies not quite work the way I expected, so we'll cover explicit dependencies a little later on in the video. Okay, let's change the name of the resource group to RG02. Then let's save the file, and let's run a plan to see it in action. If I scroll up through the execution plan to find the resource group name under the storage account, we can see that the name of the resource group has been passed to it correctly. Okay, let's change the name back and save main.tf. Let's do the same thing for the rest of the repeated values. This time we're going to use the IntelliSense features of the Terraform extension for VS Code. Let's update the location of the storage account first. Go ahead and delete the location value. Now we know that we need to get the location from an AzureRM resource group object, so I'll start typing AzureRM. When I start typing, you can see IntelliSense popping up. It knows that we have an AzureRM resource group object in our code, and it also knows that it's called RG1. If I hit Tab or click the pop-up, it fills in the resource name. But this attribute is asking for a particular value. So let's put a dot at the end. Now we see some more IntelliSense. This time it's giving us a list of attributes to choose from. This is all thanks to the Terraform extension for VS Code that we installed in Lab 1. So let's go ahead and select the location attribute. Now the last thing I want to update is the tags. I want my storage account to use the same tags as the resource group. So let's go ahead and replace the tags here using the same method. Great. Now we can save the file and run a plan to see if the changes were successful. You should see a successful plan if everything went well. Next up, we're going to go over data sources in Terraform. You may also hear me refer to them as data resources or data lookups as well. Data sources allow you to get access to information based on a resource that already exists, but is not managed by your Terraform configuration. It could have been created manually or by a different configuration, but sometimes we need the details of that already existing resource in our configuration, so we need a way to reference it. For this example, we're going to add another storage account to our configuration, except I'm not going to put it in RG01. Instead, I'm going to put it into a resource group that already exists in my Azure subscription. Under resource groups, you can see I have one called RG-Test01, and this is located in Central US. This is the resource group I want to look up in my config. To do this, we're going to go back to the AzureRM documentation and search for resource group. If you remember from the previous video on navigating the Terraform provider documentation, we had looked at the data sources section here briefly, but we're going to use it this time. So go ahead and click on AzureRM resource group under data sources. Here, we're given an example of a data source that we can use for this resource, which also gives us the arguments that are required as well as which attributes are exported. From this, we can see that the data source requires us to pass the name of the resource group into it, and from it, we can get the ID, location, and tags attributes. So let's select and copy just the data source from the example. We'll be going over outputs a little later on. Back in our main.tf file, I'm going to give myself a couple of lines of space under the storage account, and then paste the data source example. Now we just need to update the values. I'm going to change the resource name to be the name of the resource group I'm looking for, just to keep things simple. Then I just need to specify the name of the existing resource group that I'm looking for in the name attribute. Now let's create another storage account that will go into this resource group. To do this, I'm just going to reuse the storage account code from above and just change some values. I'll change the resource name to SA2, and for the name attribute, I'm going to just change it so it's got a few 2's at the end. Like I said, storage accounts need to be globally unique in their names for all of Azure, so I just like to add a few extra numbers in my testing. Now you'll notice that the resource group and location are still referencing the resource group we defined above, the one that we created. In order to reference the existing resource group, we have to do things a little bit differently. First, we need to start with the word data when we're referencing a data source instead of AzureRM resource group like we did previously. Then, you can see from IntelliSense that it follows the usual syntax for specifying values. So I'll select the data source for RG-Test01. And when we put a dot after that, we can see the attributes that are available to us from that data source. I'm going to use the name for this. Let's do the same thing for location and tags. Perfect. Now that that's complete, let's save our new changes. Next, I'm going to run a plan just to see if everything's working correctly. Since I destroyed everything at the end of the last video, I see all my resources getting created here. With a quick spot check of the execution plan, I can find my second storage account and verify that the location is in fact Central US, and that the resource group is the existing one that we saw in the portal. Now, if you didn't get any errors, let's just go ahead and apply this configuration. After the apply finishes successfully, let's go check out the Azure portal again. If I refresh, I should see the existing resource group in Central US and the new one that I just created in East US too. Let's take a look at RGTest. As you can see, the new storage account we just configured is listed here. Next, let's talk about input variables. Input variables make your code more reusable by allowing you to modify certain aspects of its behavior without having to modify the actual code. Let me show you an example. First, a variable needs to be declared in order to be used in your configuration. So let's just make some space at the top of our main.tf. Now, let's define a variable block here. I'm going to use IntelliSense here, so I'll start typing the word variable and then hit enter. I want to control the name of my storage account with this variable, so I'm going to call it sa1name. Now, technically, that's all we need to do in order to define a variable in Terraform. There's more we'll need to add, but let's save this file and run a plan. You'll notice that the command is waiting for an input now. So if we put any value in here and hit enter, the plan will continue. Okay, the plan is finished. However, nothing has changed. That's because we defined our variable, but we didn't use it anywhere. So let's go back to our code, and for the name attribute under SA1, we're going to specify the new variable. The syntax is var dot and then the name of your variable. Now let's save this file again and kick off a new plan. This time for the name, I'm going to put AC Storage 111. Let's take a look at the execution plan. You can see here that the plan will do a destroy and then recreate replacement, and that's signified by the red minus and green plus. And we can also see that the change to be made is that it is changing the name of the storage account, which forces a replacement. I mentioned in the last video that some things can be updated in place, but some require a replacement. This is one of those instances where it requires a replacement. Typically, changing things like the names of things will trigger a replacement. You'll also notice that since we define that variable, every time we run a plan or apply, Terraform will prompt us for it. That may be desirable in certain situations. However, you may also just want this variable to have a default value if nothing is passed to it. The variable block accepts an argument called default. When default is specified, the variable becomes optional, and the default value is used if no other value is passed to this variable at runtime. I'll show you more on that in the next video on Terraform variables. So if you haven't done so already, add the default argument, and let's give it a value of AC Storage 111. Save these changes and run another plan. Now you'll notice that the plan command no longer prompts us for the variable now that it has a default value. Using variables this way can be useful when you have a need to update multiple values across a larger configuration. For example, if I had a larger configuration with multiple resource groups with resources inside them, and you wanted to be able to easily set the location across all of your resources, you could create a location variable with the default value of East US 2, for example. Then, if you needed to move all your resources over to Central US, you would just need to update that one line of code and run your configuration again. Similar to variables, local values or locals can be used to store information that can be used multiple times within your configuration. To start off, we're going to need a locals block. which just consists of the word locals, then an open and close curly bracket. Inside the locals block, you can specify some key value pairs. The first local I'm going to set up is for location. And I'm going to set it equal to East US 2. You can also add additional locals in the same block if desired as well. You can also have multiple locals blocks in your configuration to help you keep them organized. Once a local has been defined, you can reference it by using local dot and then the name of your local. So for my resource group's location, I'm going to put in local dot location. Let's save that file and run a plan to make sure it succeeds. Okay, perfect. Next, let's talk about output values. Output values allow you to make information about your configuration available to the command line or to other Terraform configurations to consume. Let's start by giving some space at the bottom of main.tf under SA2. We'll specify the outputs block by using IntelliSense. You can see that an output block is similar to a variable block. Instead of variable, it's output, and then you still need to give it a name. Let's call this one SA2 ID. Outputs accept an argument called value, and that's how we're going to specify the value we want to output from this configuration. Now, to set the value, we would do it the same way that we would reference a resource anywhere else in the configuration. So let's specify our second storage account, and we're going to grab the ID. Okay, let's save this file again and run a plan to check it out. You should see a Changes to Output section. A new output will be created with the ID of the storage account that we specified. This value could then be consumed by another module or configuration. Alright, as you can see, we've kind of made a mess with our main.tf with all these variables, locals, resources, and outputs. It's starting to get a little hard to read. As I mentioned previously, Terraform will join all TF files in the directory to create an execution plan. So what we're going to want to do when our configuration gets bigger is to organize everything into different files. Typically, a Terraform configuration would have a main.tf and a versions.tf, which we already have. It also could have an outputs.tf, variables.tf, and locals.tf if any of those are in use in the configuration. So let's create those three files. Now that those three files are created, let's go back to main. Let's start with the variable here and move that over to variables.tf. Make sure you're removing it from main.tf as well. Otherwise, you'll get an error because of duplicate variables. Now let's grab the local block and move it over to locals.tf. And finally, let's move the output over to outputs.tf. Okay, let's make sure all of our files are saved and don't have the little dot next to their name. I'll also mention that you may see a data.tf file in configurations that use data lookups like we did for the existing resource group. But in this case, or cases like it, I like to leave the data lookup next to the thing that's using it, since there's only one thing using it. If this data lookup was used across multiple resources and files in my configurations, I would put it in a data.tf file, but that's totally your call. We can already see that this configuration is starting to be a little more readable. Now, if all went well, we should be able to see a successful plan. Once that's working, let's go ahead and run an apply to apply our changes. All right, the last thing we'll go over in this video is creating resource dependencies. Earlier in the video, we talked about how referencing other resources creates an implicit dependency. However, you can't always rely on that in all situations. Just as an example, let's say I wanted to make sure SA2 didn't get created until SA1 was finished. To do this, I would need to specify an explicit dependency between the two resources by using the depends on argument. The depends on argument will accept a list of resources to create explicit dependencies for. Back in main.tf, I'm going to add the depends on argument to SA2. I can use IntelliSense here to select SA1 as the dependency. Like I mentioned, this argument accepts a list of values, and a list in Terraform is specified by using the square brackets. So if you had multiple resources that you were depending on, you could add them here to this list. This can all be brought up onto one line as well. Now, we won't really be able to see this in action since both storage accounts are already created. So I'll just show you this in action really quick. Let me just pause the video for a moment. Here, I've added a resource group and a storage account. I made sure not to create any implicit dependencies between the two, and I commented out the depends on argument. So let's see what happens when I try to apply. We can see by the output that the configuration has failed to create the storage account because the resource group couldn't be found. If we look closer, you can see that Terraform started creating the resource group, then it started creating the storage account before RG2 had finished. So that's why we got the error. I'm going to pause the video, destroy that resource group, then I'll come back and try again with the explicit dependency to see how that changes things. All right, let's try that again. I've already uncommented the dependency to RG2. You can see from the output here that we didn't get any errors. You can also see in the output how Terraform waited until after the resource group was created before it started creating the storage account. Now that we've gone over how to make your configurations more flexible and readable, we're going to dive a little bit deeper into variables in the next video. Make sure to check it out. Thanks for coming, and I'll see you next time.